This lesson is on the law of cosines. It's learning target 3 in our unit on trigonometry. In the last lesson, we used law of sines to solve for the missing angles and sides of triangles that weren't right triangles. If we take a look at this new situation, will the law of sines solve for the missing side, this x? We have no a, we have a b, we have no c. We have an a side, and we also have a B side, but we do not have the C side. So if I try to set up a law of sines situation in order to solve for x, it would look something like this. X over the sine of 100 is equal to, and I guess I'd probably choose 5 or 4, I guess we'll choose 4, over the sine of angle C. This is a problem because we have both a variable for C and also a variable for X, the side C. So we're not going to be able to solve this. If I were to instead try to set it up with the A side, I would put a 5 here, and then I'd have to have an A. Same situation. I have two variables, X and A. So there are situations where the law of sines will not solve for the pieces you need. So we need a new tool. And that tool today is called the law of cosines. Just like with the law of sines, there are 3 different ways that we can use the law of cosines. Each is a different formula, but they're all very similar. It kind of looks partially like the Pythagorean theorem, followed by minus 2 and then 2 variables, cosine this time instead of sine, and then our angle. You can use any of these at any time given which sides and which angles are available to you in a problem. All you have to do is be able to plug in the right angle and sides into the right spots, and you'll be able to simplify it and get your answer. So let's use the law of cosines in a situation. How about a situation that we couldn't use the law of sines on from the very beginning? So let's solve this triangle. Let's find the missing pieces. I have an angle B. I want to find side B. I don't have angle A, but I have side A. I don't have angle C, but I do have side C. Since I have both side A and side C, and I want to find side B, I'm going to use the formula that starts with side B, because B is the side that I want to get, so I pick the one that starts with B squared. It goes B squared equals A squared plus C squared minus 2 times A times C times the cosine of angle B. Notice I'm using little letters for our sides and a big letter for our angle. Let's substitute each of these with what I have from the picture. So in my picture, I have B squared is equal to 5 squared plus 4 squared minus 2 times 5 and 4 times the cosine of 100. All I have to do is start to simplify that out, but make sure you do the simplification in the correct order. If you do things out of order, if you do not follow order of operations, you're going to get the wrong answer. So first, in order of operations, we're going to use our exponents. So 5 squared is 25, and 4 squared is 16. Now we can do the multiplication. 2 times 5 times 4 is 40, and that also will get multiplied to the cosine of 100. And now I can go ahead and multiply all this out. I end up with 47.95, but this is rounded. I'm going to go ahead and square root what's in my calculator to get my answer. So my B is approximately 6.92. So that's how you get your side B. To get side A or C, we could use law of cosines again, or we could use the law of sines. So there's 2 options. I'm going to go ahead, for sake of review, and use the law of sines. So let's use our side B, 6.92, over our sine of B, which is sine of 100. And that's going to be equal to, let's find angle A first, so let's put 5 over the sine of angle A. If you work this out correctly, you would get 45.4 degrees. And this is rounded. I'm not going to show you all the in-between steps right now because our last lesson was on the law of sines. If you're still having trouble solving an equation like this one in green, go ahead and go back and rewatch that video or check your notes. Now that I have an angle A and a B angle, I can find the C angle pretty easily. I can do that by just taking 180 degrees, subtract the 100, which is the B angle, the 45.4, which is the A angle, to get my C angle. It comes out to 34.6 degrees. And there you go. That's how you use law of cosines to find one of the missing pieces. You can use law of sines then to find another missing angle, and then use the fact that 3 angles in a triangle add up to 180 to find the last one. In this situation, I have a triangle that has 3 sides given but no angles given. The goal is to try to figure out all the missing angles. So we're going to use law of cosines to do this. Since all sides are given, it doesn't matter which law of cosines I use. I'm just going to use the one for the angle that I want to solve for. So let's make sure we have these labeled correctly. 7 is my side A, 9 is my side C, and 8 is my side B. Let's focus on getting our angle A. The law of sines that has angle A in it also is equal to A squared. So here it is. A squared is equal to B squared plus C squared minus 2 times B times C times the cosine of angle A. Let's plug in everything I know. 7 squared is equal to 8 squared plus 9 squared minus 2 times 8 times 9 times the cosine of A. Let's work out the exponents first, and I come up with 49 is equal to 64 plus 81 minus 144 times the cosine of angle A. Let's subtract from 49 the 64 and the 81. I end up with negative 96 is equal to negative 144 times the cosine of angle A. Divide both sides by negative 144 to get the cosine by itself. And I end up with 0.66 repeating is equal to the cosine of angle A. Using what's already in my calculator, I'm going to inverse cosine that decimal to get my angle A. I end up with 48.2 degrees. So there is my first angle. I can add that to my picture too to keep track of which pieces I have found. Now I can go ahead and use law of sines again in order to figure out one of the other angles using the sides I have. So I now can set up a pair of A's. Side A is 7 over the sine of 48.2. And let's focus on getting angle B first. So let's put 8 over sine B. This gives me an answer of 58.4 degrees. And just like before, take 180 minus our 48.2 and minus our 58.4 will give me my angle C, 73.4. So this is how you use both law of cosines and law of sines to figure out 3 missing angles when you know all 3 sides of a triangle. It is also helpful to be able to put the picture together from any kind of word or phrasing. So I'm going to go ahead and just draw kind of like the basic triangle. Will it be exactly what I need? No, probably not, but it will be something. So here's a basic triangle. I'm given angle A, which is 51. So I'm going to go ahead and label this as 51 and angle A. I'm going to label the next angle as angle B, and the next angle after that, angle C. Across from angle B is side B, which is 40, and across from side C is angle C, which is 45. I don't have side A, I do have side B, and I do have side C. Since I have side B and C, let's use the law of cosines that will find me side A. A squared equals B squared plus C squared minus 2 times B times C times the cosine of angle A. Let's start the substitute. A squared is equal to 40 squared plus 45 squared minus 2 times 40 times 45 times the cosine of 51. I'm getting some pretty rather large numbers, but just go with it. I end up with A squared is equal to 1,359.4. And don't forget to square root both sides. And I get 36.9, which is rounded for our A side. Now that I have an A side and A angle, let's set up a law of sines. Law of sines is going to be 36.9 over the sine of 51. And we can work on either angle C or angle B first. So let's work on angle B, 40 over the sine of angle B. Solve that law of sines, and your angle B will be equal to approximately 57.4 degrees. And then using our 180 degrees for a triangle, we're going to get our angle C. 71.6 degrees. There you go. Was this triangle a very good representation? No, probably not. I probably could have drawn it better. It doesn't really matter what the triangle looks like as long as you can put A, B, and C, label the pieces, label the sides and angles, and pick the appropriate law of cosines to solve for your first missing side. We can always use law of sines to help us find other missing angles. If you don't like this, in class I can show you how to find missing angles if you don't want to use law of sines. Don't forget to click forward, answer the questions after the lesson, and hit the submit button. If you do have remaining questions, you can always text me, or you can write them down, and we can talk about them when you get to class.